until researchers at the University of Washington figured out a way to 3D print devices that can use Wi-Fi to communicate with other devices like smartphones without the need for batteries or electronics. Instead of sending their own signals, the devices used an antenna to reflect these waves and talk to other receivers. The antenna was made using a 3D printer and consists of composite plastics which are conductive thanks to copper and graphene filings. But just making an antenna to reflect ambient Wi-Fi wasn't enough. The researchers needed a way to modulate the reflected waves and encode information. Once again, 3D printing was their answer. A switch was attached to a spiral-shaped spring, and a gear pressed against the spring. When the gear spun, it forced the switch to rapidly make and break contact with the antenna, quickly changing the amplitude of the reflected signal. The spikes and troughs in the signal can be used to represent ones and zeros, and voila! A 3D printed Wi-Fi device that uses mechanical motion instead of electricity. Something like this could have a huge range of applications, so long as whatever it's attached to is providing the movement of the gear in some way. For example, it could be connected to a flow meter where moving water or another liquid causes the gear to spin. The students used the example of something attached to a detergent bottle that detects when the bottle is running low and automatically signals your smartphone to order another one. If you're not into the idea of a branded detergent automatically restocking itself ad infinitum, the flow meter could help keep your home secure. It could be used to detect if a pipe springs a leak and alert you before the water does serious and expensive damage. And because the flow meter wouldn't require batteries that need to be changed, that's one less thing to worry about. The researchers' invention could also find use in hospitals to keep drugs secure. The mechanical motion of twisting the cap off of a pill bottle could be used to track when the bottle is opened. Even if the bottle is taken out of range of the Wi-Fi signal, the researchers have discovered a way to store data and then upload it with the push of a button when the bottle is in range again. The researchers have created several widgets using their technology, including a button, a knob, and a slider. And they've made their CAD models open source and available for free. If you have a 3D printer at home and the right materials for the job, like the composite plastic for the reflective antenna, you too could festoon your house with bells and whistles of buttons and switches.